Your lab number 3 is due next week. If you need some extra help, basically you can come to any of the lab sessions this week, any of them. However, just do come after the first 90 minutes, after the lab test. You can just come, or myself and the TAs, we will be there to help you with lab number 3. You don't want to wait until the weekend to start your lab number 3. You wouldn't have enough time, okay? So that's an extra help you can get for lab number 3. Okay, today I would like to divide the lecture into 2 parts. The first part, I would like to just continue with our object orientation lecture. I'll just go smoothly, try to develop from what we learned previously. And then I would like to enter new topics for the second half, loops, iterations. I know you learned a little bit basics about loops, so today is mainly going to be about just some basic syntax, and then we'll gradually get more and more complicated. So the loops lecture is already on the lectures page. You can feel free to study ahead, and things can get very tricky when you talk about loops. And for lab test 2, which is going to happen 1 week after the reading week, lab test 2 will be about loops and also arrays. So that's something we're going to make sure we cover in the next few weeks. Okay, let's now continue with our object orientation lecture. Okay, let's do that first. I'll do roughly about 1 hour on this, and then the rest of the time I'm going to spend on the loops. Okay, so now I would like to start with, as we go towards the end of the course, things will get more and more complicated, especially when you talk about classes and objects and also methods. Inside the methods, you may have if statements, like what you have been doing for so far in your labs and also in the practice lab test. Later on, we're going to see that in the methods, you may also have iterations like loops, which we'll start covering from today. But I think the most important technique you really want to have is to see how we can visualize objects at runtime. Basically, every time when you say, for example, person Jim is assigned to new person, and then with some information there in the constructor, you're trying to draw a rectangle box and then to put it aside. Every time you have a new keyword used, you should really draw a new box. And then eventually, you may have several objects you want to manipulate by each other. Okay, that's kind of the thing you want to gradually build. I just want to go over with you with some example. Okay, so now the example I'm going to want to give is like this. Okay, I'd like to just go over a block of Java code with you first. That shouldn't be too strange to you. It's a slight extension to what we learned from lab number 1. Okay, let's just go over that very quickly. So this example here shows again attributes, constructor, accessor method, and mutator methods. I will also use this lecture example here to explain again what each method means and also how we can trace the code. Okay. Okay, first of all, you can see that we have a person class over here. And then you can see that the way we lay out attributes and methods kind of following the pattern I suggested to you before. You don't have to really exactly follow the pattern, but that's just recommended. Okay, let's try to see what's going on here. First of all, this section over here, we have all the attributes. And this section over here, we have just, for now, just one single constructor. But as we learned from last Monday, for the point class, we actually introduced another second kind of constructor, where the first argument can be a character, telling you whether that should be on the x-axis or y-axis, right? That's also something you can, but in general, you can have more than one versions of the constructor for the class. Let's just talk about just one for now. And also we have also get BMI. Also we have another method over here. So now the question is, how do you tell from attributes to methods? How do you distinguish between them? The best way to tell is, you can see that, for example, let's say age. How can we see that it's an attribute? It's simply because there's no left and right parentheses after that. But what about, let's say, get BMI over here? Why is that a method rather than an attribute? It's simply because you got this pair of round parentheses over here. That's how you tell. Okay? And of course, within the pair of parentheses, you may have more than one parameters. Sometimes it can be just empty, which means no parameters. Okay, so now again, so here we got attributes over here. You simply just get basically the types. It can be integer, string, or double. So these are the types, and also the name of the attributes. And over here, this is a very special kind of method which has exactly the same name as your class. It's called constructor. Okay? You have no freedom whatsoever about the name of the constructor. It can be just the same as your class name. Okay? And then this one over here and this one over here. Oh. All right, we are fine. I thought it's actually some alarm, central alarm. Yeah, that's okay. Okay, let's continue. Okay, how about this one and this one? Let's now focus on these two, okay? So now you can see that over here we got double over here versus void. Okay, this is how you can tell. First of all, these two are methods because you can see the left and right parentheses after that. So these are methods for sure. But one is called accessor, the other one is called mutator. The reason that we can tell this is accessor, at the same time we can tell this is a mutator. Why can we tell that? You have to see the so-called return type. So I'll highlight that for you. Okay, so now over here, double versus void. So these are so-called return type. Return type. Okay, so this is the principle. If the return type happens to be just void, so void is a keyword in Java. As soon as you see void over here, that means it's a mutator, no question about it. If you see anything other than void, that means it's accessor. It's that simple. Okay? If that's void, that's a mutator. If it is not void, and you also got parentheses around, that means it's accessor. Okay? So for example, the practice test I gave to you for lab test 1, all the methods I asked you to do were accessors. They all return something, integer, character, boolean, or double, okay, or string. Okay, so now, whenever you identify the methods being accessor, what does that mean? That means you must have at least one return statement. Typically, it should be at the end. I know many of you sometimes got a syntax error, something like unreachable statements, or you're missing return statements. So these are the common errors that you actually encounter for accessor methods. So I would suggest the best practice would be you just have a single return statement at the end. And the value you're trying to return, for example, BMI over here, what's the type of BMI in this case? It's exactly double type. And the double over here matches the return type for your method. That means I'm returning something as the return value for this method. Okay, it has to be double in this case. Okay, let's go to the, so now for accessor, that means usually just return statements required. Return required. Okay, there's got to be at least one. But I would suggest, for you as a beginner, put it at the end. Okay. Now, let me just talk about the common error you might have. Okay, let's talk about it. Let's say this. If I have integer, let's say, I'll just say m, just make it very general. And then I have, let's say, character C over here. Something like that. Okay? Now, I can say, let me just show you something. First of all, we can see that this is an accessor for sure, because we have some return type that is not void. But now, let me show you a very common error. For example, I will show you two. First one, if I simply say, I simply want to return, you know what, let me just make it a little bit more interesting to you. Slightly more interesting. Let me just turn this to Boolean. Okay? I simply want to know if the character C over here is either P or K. P or K. If it is P or K, return true. Otherwise, return false, either P or K. Okay? So now I can just modify the name of the method over here. Let me just put it a more meaningful name. P or K. Okay? Now let's see, let me show you one common mistake. If I simply say the following, let's say I want to just declare some local variable here, only within this method here, I would say result. Okay, like that. Result is assigned to, initially I'll just say false. Okay, I haven't really made any decision, so I'll just give some false just to begin with. Now I can say that something like this. If character C is equal to, let's say P over here, or C equals K. If this is the case, I would say result is reassigned to true. Okay? Otherwise, it remains to be false, which means it's neither P nor K. This is a very common mistake. Can you see why? Remember what I said before, if it is an accessor, return is required. Okay, that's the first very common mistake. So now this one here does not compile. Not compile. Because missing return statement. Missing return statements. Okay, so now how can we fix it? Okay, well, since like if I look at your code manually, I can see roughly what you're trying to do. So what you should have done would just adding a new line. So I want to make sure I return the result I have been manipulating result like that. That's what I got to do. Okay, that's how we fix it. So that's why I said to you, it's actually better to actually have your return statement as the last line in your code, in your method. Okay, that's the first common mistake. Let's do another one. Okay, another one. Okay, let me just repeat exactly the same method over there. Okay, let's do the following. Let's say Boolean, and then we'll say P or K. And then we have some character C. Okay. The one I want to demonstrate is we do have the return statements, but somehow, funny enough, it still says missing. We may not return. What does that mean? I'll show you here. We can say that if over here C equals P or C equals K. Okay, let's say that. So now let's say we do not have the intermediate variable as we did in the previous example. Let's say we just want to return. Okay, sometimes you might find it's more concise if you write it this way. I can say return, let's say true. Okay, now what's wrong with this? Well, I do have a return. I do. But this one still does not compile, I can tell you. But why is that? I do have a return. Nothing to do with local variable. As you can see in this example here, we don't have any local variable. The only local variable we have is the parameter C. That's the only one. Yes, at the back? Yes, go ahead. The one in green? Yeah. That's exactly right. So basically the problem with this is in the case where C happens to be P or K, we're going to return. But what if, let's say, C happens to be A, for example? In that case, let me just give you a counter example. Okay, so this one here, not compile. Okay, does not compile. And then, in this case, let's say, just for example, I'll give you a counter example. Let's say C happens to be character A. Okay, what's going to happen here? A equals P, false. A equals K, false. False or false? False. In that case, we're going to completely bypass the return statement over here. That means we'll go directly to the next statements, in which case nothing. So there's still a missing return statement. Okay, so that means missing return statements when the if condition is false. Okay, are we okay? This one's slightly more complicated. Okay, let me do you another one. And this one I kind of observe just from your lab. Okay, that's an interesting one. Okay, let me do the same thing over here. Boolean over here. Okay, the same method. P or K. And then character C over here. Let's say this time I try to be very cautious. I say if C equals P or C equals K over there, in that case, I return true. Okay? And then otherwise, return false. Okay? Now, let's say I'm not done yet. Let me just put another line here. Let's say somehow I just, for some reason, I say Boolean result is assigned to C equals P or C equals K. Okay? And then I would say return result. So basically, I'm trying to do two things that are individually correct. So if you think about this part over here, I'm trying to either return true or false based on the truthfulness of this Boolean condition here. That part is correct. Logically, it is okay. And this part over here, I'm trying to do some intermediate variable result, and then simply say the value for this result, which can be either true or false, is going to be the result of evaluating this condition here, which can be true or false, and then return the result. I combine these two together, one after the other. Well, that simply means I'm going to return it seems to me, I want to return the correct result twice. Okay? Is this going to compile? Okay, I can tell you that this is not going to compile. Okay, but why? What you will see from Android Studio is it's going to put some red underline over here, and then it's going to say, okay, not compile, unreachable statements. I'm sure some of you actually have seen this kind of error already. Unreachable statements. Unreachable statements. So this issue here is kind of the opposite of what we just have seen in the previous example. But let's just try to understand. In the previous example there, we say that there's a missing return statements in the case where the condition over here evaluates to false. Okay? So there's a missing case. However, over here, we do have, over here, let me just highlight it to you. We have the if, we have the else. As we learned before, else simply means whatever the previous if statement that does not evaluate to true, we're going to execute as a default case right here, no matter what. Okay, it's guaranteed to have some execution. So now, if you think about it, this single if statement here, it is going to return no matter what. Agree? Why? Let's try a different example. I'm going to try two cases. What about, let's say, if C happens to be, let me use green to mean that's going to make it true. If C happens to be P, for example, okay, that means P equals P, true. Once it is true, it doesn't matter what the other side is, because true is, or something, well, as long as the one side is true, the whole thing is going to be true. In that case, we're going to return true. Okay, let's talk about the other case. The other case, let's say we got, let's say, character A. What about character A? For character A over here, we're going to have A equals P, which is false. Or A equals K, also false. False or false? False. That means we're going to execute return false. So what does that tell us? That means for this particular if statement over here, since we got the else part, it's going to execute the else part in the worst case if all the previous if statement, if conditions evaluate to false. And what does that mean? That means we're going to return from this if statement no matter what. And once you return, that means the method is over. And there shouldn't be anything further to be executed. So that's why these two lines, in some way, are useless. That's what the compiler tells you. Because from the previous if statement here, it's guaranteed it's going to return either true or false. And why do you still have to put these two lines? They wouldn't be executed anyway. Okay? Guys, is this example clear? There's something called unreachable statements. So this one is, again, slightly more advanced. But I think all the three examples I talk about, I think they are the common mistake, which you want to avoid. Not just in your labs, but when you do your lab test, not just lab test 1, 2, and 3, you want to avoid this kind of error. Okay? Questions about any of the examples? Are we okay? Okay. Or you can rewatch the recording to see if you want to find out more. Okay, so now back to the accessor versus mutator issue there. So what we just covered was the accessor. Okay, you always have a return type, and it's recommended you only put a single return statement at the end of your method. Now, when we talk about mutator methods here, this will be something we'll try to cover more, possibly in your lab test 2 and 3. So mutator methods means, so mutator methods usually, that means they will have to change, typically, change attribute values. That means the attributes over here, okay, over here. So that would be what you can change. So you can see, for example, in the case of gain weights by certain units, you're trying to change the weights units over here, okay? And the weight is exactly this attribute over here. Okay, that's one way to see it. Okay, are we so far so good? Okay, I'm just trying to go over all the code and then to review the terminology. Okay, now let's see how we can make use of this block of this class over here and see how we can visualize the objects at runtime. Let's make sure we do that properly. Okay, so now I'm just going to go to a new page and then I will just add another one. Okay, this one, exactly the same. Okay, now let me go back to the slide and we'll do statement by statements. Okay, let's say the first one. So basically, visualizing object at runtime is very important. We want to know how objects are manipulated. I'll give you examples over here. Okay, we're going to see different statements over here, let's say sequentially. First of all, we want to see what does it really mean when we try to use the constructor of a person class or any other class and use a new keyword. Okay, what does it really mean? How do we draw diagrams to visualize it? And then the more important thing to trace is whenever you try to say, for example, Jin, which is a particular variable that stores a person object address. So what does it really mean when we say Jin.getBMI? Apparently, you can say getBMI has a parenthesis over here. It's a method call. Okay, and then I'll go in a little bit more details into this. Okay, that's one thing. So this is called an accessor method call. Okay, and then with the same object over here, we say Jim.gainWeights by 10. So now in this case, we know that we're going to do something to change this object over here. But how do we do that? I'll also show you. Okay, now, first of all, let's talk about how we can visualize an object. That's how you should draw. Draw a rectangle box, and then you're going to have title, left column, right column, etc. You can read through the slides, but I'll show you an example. And then you have to draw arrows to represent which variable actually store the address of the objects. Okay, that's something we're going to see. Okay, and again, it's about address. Okay, it's really important. Okay, let's go to the next one. Now, how do we visualize this guy over here? Okay, I'm going to keep the line in the slides, but I'm going to draw on the iPad, okay, to show you. How do we draw this one here? First of all, how many attributes do we have in the class? Okay, you can see that over here, how many attributes do we have? We have 1 attribute, 2, 3, and 4. This shows you how complex your rectangle should look like. Okay, so now let's visualize exactly the effects of this line over here. First of all, the right-hand side. When we say new person, 50, British, 80, and 1.8. So what do we do over here? Okay, so what we're going to do is, okay, actually, you know what? For this one here, let's try this. Maybe it's also good for me to put it here. Okay, so now we'll say person, Jin, is new person. Okay, and now the sequence of the input matters. You can see that in the constructor over here, we're expecting the first one to be integer, second one to be a string, third one to be a double, and the fourth one to be a double as well. Okay, so it must match. You cannot just randomly order your input values. Okay, in this case, what we have is 50 British. Okay, so let's say 50 over here, and then a string, British, and then 80, and then 1.8. Now I have a question for you. You can see that this line here should compile because, first of all, person is a constructor in the person class. So it's a known class. That's okay. And then 50 here is an integer, no problem about it. It's an integer literal. And double quote, British, is also a string. And 80 over here is also a double. And 1.8, no question, also a double. So it will compile, no problem. Question for you. What if I wrote the following? Let's say I accidentally wrote 1.8 and 80 here. I swapped the order of the two inputs. Do you think the compiler can tell me that I got something wrong? No, in this case, no. Because even though we gave some meaningful name like a W and H, but what the compiler would do, they wouldn't really be able to tell that 1.8 should be the extent for some weights, and 80 should be the extent for some heights, right? The compiler is not intelligent enough to tell that. All they can tell is whether the value you pass over here as input match the type over here. If they're double and double, then it's fine. Even if I put 0 and 0 over here, it doesn't make any real sense. Nobody can have a 0 weight and 0 height. However, compiler can say only tell it's a double, so it doesn't matter. So you got to be very careful. That is something that you want to avoid logically. That's not something the compiler can reveal for you. Okay, that's just an aside. Okay, so now, how do we visualize this? First of all, we know that we have a new keyword over here. Oh, sorry. We have a new keyword over here. So now we're going to draw a box, rectangle box. And then we're going to give every box a title to indicate what type of objects are we dealing with. In this case, since it's a person object, so we put person over here. Now, how many rows should we have for this box? It depends on how many attributes we have over here. So now when I was trying to help you with your lab 1 and 2 and 3, I found that sometimes you make too many variables in your, make too many attributes in your class. I would say the good design principle is you want to minimize the number of attributes. You can see that if you got many attributes here, it will be very troublesome for you to draw the box. It's for efficiency reason. I would say whenever you can make your attribute to be local variable, make it local to the methods. Okay, that's a design principle. But we'll talk more as we see more example. So now we see exactly 1, 2, 3, and 4. So let's draw that 1, 2, 3, and 4. And the first attributes, I would say A for age, and also N for nationality, W for weight, and H for height. Okay, I got 4 attributes. Okay, if I have more attributes, the box should be bigger. If I have fewer attributes, the box should be smaller. Okay, now, and then, now how do I fill in the value on the right column over here? You can see that over here. So we got 1, 2, 3, and 4. So these are the 4 values we have to fill in for each object. Okay, in this case, how do we do that? So there will be a very important keyword for you to learn, okay, over here. It's called this. Now, I also got some slides later, but we can talk about it right away, over here. Let's look at the contents for this constructor here. When I say this.age is assigned to A, what does that really mean? And when we say this.nationality is assigned to N, what does that mean? Okay, it's really important, okay? First of all, let's have a look at over here. You can see the A over here. A is without the this. So now in this case, it just matches the A over here, A and A. That refers to whatever input value you give to this constructor over here. And now, on the other hand, let me use green. When we say this.h over here, this part I'm highlighting, this.h, since I'm using this, you can think about this means whatever context objects I'm talking about. For example, over here, when I say new person, so this is a context object. This is a context object I'm trying to create. This. Okay, context objects. Okay, so now when I say this.h, so what does that mean? This.h, this is a context object over here. This.h is referring to this particular attributes. Okay, so this is this.h. Okay, so when we say this.h is assigned to A, so that means, and this is A. Right? Because we are trying to call this particular constructor, and 50 is going to 50 is going to be used for HA over here. Okay, so every occurrence of A is going to be replaced by 50. Okay, let me just be more precise over here. So that means 50 over here for the A, and this is also 50. That means this dot H is assigned to 50. And then we put 50 over here. Are we okay so far? Okay. Now, what about the second one? British. So now you can see that the string N over here standing for nationality. So now over here is going to be replaced by British. And then you can see the N over here is also going to be replaced by British. So what is this dot nationality? That's the question. Whenever you see this, that means you should know what the context object is. In the case of the new keyword, the context object talks about the new objects we are trying to create. So that's the context object. In this case, this dot nationality is exactly this attribute over here. So this guy here is this dot nationality. I'll say N. Okay, this dot nationality. And now we say that it's going to be assigned to British. Okay, I'll just say British here. Okay, similarly, you can see the weights. This dot weight is assigned to W, which is 80. And also this dot height is assigned to H, which is 1.8. So that's what we got. That's how we fill in the attribute values for the objects. Okay. Now, we have just completed the right-hand side over here. Now, what about the left-hand side? The left-hand side basically means we are declaring a variable called Jim. It's a variable. Now, if you look at the type over here, person, this is how you can tell. In Java, the convention is anything that's capitalized means it's a class. Person, string, scanner, taxpayer, right? Or utilities, right? Anything that's capitalized means it's a class name. Okay, so person over here is a class name. Whenever you use a class name as a type, as opposed to int, double, char, or float, things like that. So that means the variable over here is going to store the address of some person objects. It's going to store address of some person objects. So this is something I have repeated quite a few times in the tutorial video and the lecture, but it's really worth repeating it. Okay, of some person objects. Okay, so now the way we say that Jim is going to store the address of these objects. Okay, we talked about how you can use a binary address, right, in the previous lecture. For now, I'll just go directly to the conclusion. How can you draw that? Basically, you just put the variable name over here. So Jim does not represent the entire objects. So we wouldn't just put Jim over here. That's not the way to go. Okay? What I would do is I'm going to say that Jim is going to store the address of this particular object. So I will simply do Jim is pointing to this particular object. Okay? It's about the storing the address. So in 2031, later, you're going to learn about the C programming language. So you got this kind of address arithmetic, even more complicated way of manipulating addresses. But for Java, you just have to know whenever you see a variable that's declared as a class type, in this case, that means a variable is going to store the address of some objects. And the way to visualize it is to draw an arrow like this. Okay? Guys, are we so far so good? Okay. Okay, once we understand this, we have to know, given some variable like Jim, how can we do something to it? Okay, either you can say, given Jim's weight and height, we can ask what his BMI is. That's asking a question, which means we're going to call some accessor method on this Jim objects. Or we can say, over time, Jim has gained some weights, in which case the value for W might just increase from 80 to 90, for example. In this case, we're going to call some mutator method on Jim to say, now we want to change the W value by 10. Okay? So these are the two types of things you can do on an object, the typical things, either accessor or mutator. Okay? Okay, let's go on. Okay? I'll get to the same example in just a moment. Okay, let me I'll just go back to slide for a moment first. Okay, let me just use the same code over here. like that, okay? Okay, so that's about how you can draw it. You don't really have to draw something like in-depth complete details. As long as you can actually know how things are going, you're okay. But I would suggest try to be as precise as possible. That's why I'm trying to show you how you can draw it. And this technique will be quite useful also when you go to 2030. Because in 2030, we don't use tablets anymore. We only try to use tester, like how I have forced you to practice for the lab test. Later on, when you only have the tester to trace your program, your best friend is to visualize the objects. Okay? So let's try to practice from 1022. Okay, now let's talk about what does it really mean when we try to call an accessor method. What does it really mean? Okay, the assumption is we already got this object over here. Let me redraw that very quickly. Okay, we already got this object here from the constructor, which means we have Jim, and it's pointing to some objects of type person. And then because we got 4 attributes over here, we got age, we got nationality, we got weights, we got heights, and then we got exactly 50 and British, and then we got 80 and 1.8. Okay, that's what we developed from the previous line. Now let's see exactly what it means when we try to do Jim.getBMI. What does it really mean? Okay, let's not worry about the double BMI on the left hand side. Let's not worry about it in just a moment. Okay, so now let's say we try to do this line here, Jim.getBMI. Okay, what does it really do? Let's try to be very careful. Okay, now how do we know if this line is going to compile? Let's be very careful. Okay, now first of all, we have to know what's the type of this variable. What's its type? How do we tell? We got to go back to its declaration. If you go to the previous node over here, we know that this is how we declare Jim to be. Over here. So that means the type of Jim is person. Okay? That's how we tell. Okay? You just go back to the declaration. Okay? So now the type is person. And then the dot notation simply means go to that particular object in the memory and do something about it. Because we know that Jim actually stores the address for this particular object. When we say Jim dot over here, what does dot mean? I'll write it here. That means go to the memory location as indicated by the address stored in Jim. Just go to that particular memory location, which means we just go to this particular objects. The dot means it's more like an address lookup. Okay? That's why it happens in the hardware. Okay? But you don't have to know exactly how we look it up. Okay? So now when we say Jim.getBMI, because we know that the type for Jim is person, and then whether this will compile or not depends on whether getBMI is a method that we declare in the person class. Is that the case? Yep, because we do have a method called getBMI. So this is okay. For example, if I simply just say something random, for example, if I say Jim.get, let's say BMI, for example. Conceptually, they are the same. However, this wouldn't compile. No, this will not compile because Jim is of type person. And getBMI, everything is case sensitive in Java. So when you say getBMI in all lower cases, there's no such method name in the person class, so it wouldn't compile, right? Okay? Okay, just make sure you understand that. Okay, now, given that this will compile, let's see exactly what's going to happen. Okay? Okay. So now I will do I'll just do it here. Let me do it again. When I say Jim.getBMI, okay, this is what it will do. is going to go to see the get BMI method over here, and then this is the body of implementation, the body of method. Okay, so what we're going to do is we're going to apply the same lines of code in the body of implementation for this method, according to what the attribute values are for the context objects. Okay, let's see exactly what I meant by this. So now, if you try to look at these two lines over here, the first line, we say double BMI is assigned to this.weights. But what do I mean by this.weights? Again, remember the principle I just said before. What's this? This over here is the context objects. So now, in this particular method call, what's the context objects? Jim. Okay? Jim is the context objects. That means that this over here essentially is going to be instantiated by Jim. Okay, I'll just write it here. So that means it's as if we said Jim. So this.weight is going to be instantiated into Jim.weights because we are making this particular call over here. If you change the context object to be someone different, for example, Jonathan, if you say Jonathan.get BMI, that this will be replaced by Jonathan, right? Depending on which context object you're talking about. So the context is very important whenever you make method call in Java. Okay, similarly, whenever you say this.height, it's going to be equivalent to Jim.height, this.height, also Jim.height. Now, if you look at that, what is that going to be? It's going to be this.weights, Jim.weights. Jim is over here, is storing the address for this particular objects. When you say Jim.weights, it's going to be exactly this attribute over here, right? So this one over here is Jim.weights. I'll say W for short. And similarly, Jim.height is also going to refer to this particular attribute for this object, right? So this is Jim.height. In this case, 80 divided by 1.8 squared, right? That's kind of how we apply the formula. And after this, notice that this is also important, and also essential for a accessor method. We're going to return. What does that mean? That means whatever result we get from the previous line over here, this line over here, we're going to calculate some result and store that into BMI value, right? The BMI variable. It's going to be exactly 80 divided by 1.8 multiplied by 1.8. That's how we calculate BMI. And store that particular value in a local variable called BMI. And then we return this BMI value as a return value for this method. Okay, so far so good? We're just returning something. When you return something, who is going to receive it? That's the question. Whenever you try to call the accessor method, which returns something, how do you capture that value? So there are two ways you can capture that. Okay, I'll show you both. So now, you can either say store or capture, or let's say catch. Catch return value from an accessor method call. Accessor method call. Okay, how do we do that? Okay, first of all, we know that when we say Jim.get BMI, Jim.get BMI, again, a very quick review. We know that Jim is the context objects. Okay, given that Jim is a context object, when we say get BMI, it's going to execute the definition of get BMI according to Jim.weights and Jim.height, as we saw before, right? So this will be Jim.height, also Jim.weights, as we saw from the previous notes. Okay? So now, that means this particular call over here is going to return something. whatever the local variable BMI over here is going to store, right? We're going to return something. So this is going to return a value that is equal to 80 divided by 1.8 multiplied by 1.8. Okay, there are two ways you can do, there are two typical ways that you can do with this return value. You see, if you simply just do this line over here, that means the return value is simply used nowhere. It's not used. It will compile, but it's not very useful. So there are two ways you can do it. The first way is you can simply print it out. You can either say, let me just use this here. You can say system out of print line. I'll just say print line. That's one way you can use it. Okay, that's pretty much actually what your practice test has been telling you. Call the accessor method, print it out to the console. Okay, that's one way to use it. Another way to use it is a little bit more general. We don't want to print it out right away. We want to store that somewhere because we know that the value over here is going to correspond to the return type for get BMI, which is a double. So we can just use another double variable to store that and then use that variable later. Okay? So what we can do is, another way, second way. I'll say that's number one. What about number two? Number two is, let's say again, we make the same method called gym.getBMI, which is going to return to us some value there. We just want to capture that and store that somewhere. Okay? The way to do that is you can say double. Let's say, I would say result, for example, is assigned to this value here, right? You can see that over here, gym.getBMI is going to be some double value, which is guaranteed, again, by the return type of your getBMI method, okay? It's going to return a double value, and then you just store that somewhere, okay? Right, are we okay about this accessor method, okay? Okay. Now, you can see that typically the accessor method does not intend to change the attribute values. We just want to do some calculation according to the attribute values, depending on what your context object is. It can be Jim, can be Jonathan, can be any person objects, and then return the value. Now, things will get more interesting when we talk about mutator methods. Okay, we'll talk about it. Okay. Okay, so you can read it through. Okay, the same idea. You can see that basically the object I show over here is exactly the same object as I show here. Because when you say gym.getBMI, you do not modify any of the attributes value for gym. Okay, let's get things more interesting. What if I try to call a mutator methods? Mutator literally simply just means it's going to mutate something. It's going to change something. It's going to change either gym.name, gym.weight, gym.height, or gym.nationality. So these are the four possible attributes you can change. Okay? So let's see exactly what's going to happen. Okay? Okay, again, I'm going to also put the image back. And then we'll see that. Okay, so exactly the same block of code. But now this time, we're going to focus on the mutator method over here. Gain weight by. Okay, that's something we're going to see. Okay, now let's have a look at that. Now again, I still have this particular gym variable as you can see from the very beginning that we got this new line, we got this new keyword, right? Let me just keep that objects. Okay, let me just copy that very quickly. Again, you got this rectangle box over here, and you got person, and you have your four attributes over here. Name, age. Age, nationality, weights, and heights. Let me just be consistent. 50, British, and then we got 80, we got 1.8. Okay, so far so good. Now, what does it really mean? When I try to do the following, when I say gym dot gain weight by, let me just say 10 to be consistent with the slides. Okay, of course you put a semicolon afterwards, right? Now be very careful with this. Let's try to apply the same analysis as we did before. Okay. Now what's the context objects? Again, you can see that we are again trying to use the dot notation over here. Whenever we use a dot notation, that means based on the context object, locate where it is in the memory. Okay? So now you can see gym over here. Again, that's a context object. And then the dot means go to wherever gym points to. Okay? I'm trying to use a slightly different explanation from the previous one, but they are equivalents, just showing a different way of understanding it. We know that gym is pointing to this particular object. Okay, so that means gym dot means we go to that particular object. Okay, wherever gym is pointing to. Okay, now let's see this. We know that gym is of type person. Okay, person over here. And then we do have a method called gain weight by. So far so good. And the value 10 over here matches the double constraint over here. So far we are okay. But now we want to see exactly what's going to happen when we do this. Okay? So what we got to do is we're going to focus on the body of implementation. So this is the body of implementation. And in this case, it's a very simple method. It just happens to be just one single line. However, you should be very careful. Over here, when we say this over here, you can see this dot weights is assigned to this dot weights plus units. The units over here, you can see that, let me be clear. The units over here is referring to the parameter over here, right? And in this case, because we know that we're passing 10, so that means units will be instantiated using 10. Okay, let's put 10 over here. Okay, it's going to be 10. And now, what about this dot weights? This talks about the context objects for this particular method call. And this will be instantiated just by gym in this case. So let's just, let me use a different color here. How about pink? So now that means context object is going to be gym. So it's as if we say gym.weights is assigned to gym.weights plus 10. And what does that mean? So now you can see that this single equal means an assignment. We want to change something to something else. Let's look at the right hand side. What's gym.weights plus units? Gym.weights, just weights, plus 10. You can see gym.weights is over here. This is gym.weights. Gym.weight plus 10 will just be 80 plus 10. Because we know gym.weight at the moment is simply 80, so that'll be 90. That's the right hand side. And then this is an assignment here. Whatever we evaluate to be the case on the right hand side, store that into the variable or location that's indicated by the left. What's the left? This dot weights. And what's this? Gym, because gym is not the context object. So gym.weights is this location over here. So that means we're going to replace this value over here by 90. Replace this by 90. So that's how we did it. Any question about this? In general, of course, you can have many lines of code for your mutator method or accessor method. But every time when you do this, remember to replace this by whatever context object you're talking about in the method call. Okay? Now, if you look at the slides over here, you can see that that's exactly how we're going to see. Right? I just simply make it explicit. Replace 80 by 90. So now, by calling the mutator method, we actually change the attribute value. But there's a very common mistake, which I really want to show you. Very common. Now, let's talk about accessor method call versus mutator method call. Okay, let's review that very quickly. Accessor method call. Okay, as we said before, we can either say print line over here, and then we can say gym.getBMI. That's one way to do it. If you want to use the value and print it right away, that's one way to use it. Another way, you want to save it for later. You can say double, maybe result, is assigned to maybe Jim.getBMI. Okay, that's what we learned before about accessor method call. Now I'm going to show you a common mistake for mutator method call. Okay, mutator method call. A very common mistake is as follows. When you say, let's say I want to print out, I would say print line. And when I say Jim dot gained weights by, and then I pass 10 over here. This might make sense to you, more or less, but it's not going to compile. Why? We want to know why. Okay. Okay. First of all, you can definitely try on the Android Studio. To save time, I'll just tell you why. Okay. You can definitely experiment it yourself. Okay. First of all, does not compile. Okay. Why? Because let's be more careful over here. Whenever you want to say print line, that means you must have a value to print out. Okay. Now, when we say Jim.gain weights by 10, what will be the value for us to print out though? In the case of Jim.getBMI, we know that the BMI value is going to be returned by the getBMI method. So we do know there's a value over there. However, for this gain weights by, as we said in the very beginning, the gain weights by method over here, it returns void. That's why we say that it's a mutator method. Void means it does not return anything, which means whoever is calling it, they cannot take any return value from that. Right? Again, you can see void simply means mutator methods. Mutator method, okay? That means no return value to be used. No return value to be used. Okay? Simply no return value. So now, if you look at that over here, gain weight by over here, we know that it simply just return void. No value for it to be used. So no value can be printed out. You might be thinking, maybe you would just print out void. No, it's not the case. Void is only a syntax there telling you this block of code is not going to give you any value. You're simply going to make some changes to the objects. That's it. Okay? But you just cannot print void. Similarly, another common mistake is as follows. If I say double some result is assigned to Jim dot gain weight by, let's say over here 10. It's a similar concern over here, right? Because you can see that if we try to do something in assignments, on the right hand side, we do expect some value to be there so that we can store that to the left hand side. But now, there's no value whatsoever from the right hand side because on the right hand side over here, this is simply just void. It's not going to return anything. There's no value for it to be stored. Okay, that's why. Okay, so this one also does not compile. I'm pretty sure you will run into one of these errors later, but just always remember, if you do run into this trouble here in the labs, check the notes. And make sure you don't really have this kind of mistake in the lab test. Okay? Any questions about this? Okay, let's go back there. Okay, you will see that over here. Now, I want to conclude this particular topic over here by summarizing everything over here. Okay? Let's consider all the lines that we talked about so far, and then I'll do one more time for the visualization. And that's a very typical exercise which you have to get familiar with doing. Okay? Let's now consider, again, let me just go back to my code over here. Image, photos, moments, and this one here. Okay? Okay, the same block of code. Let's now consider the 4 lines. First of all, line number 1, we got person Jim. It's assigned to new person. Oh, over here. Okay, thank you. Okay, so the first line over here, person Jim is new person, and then we got 50 sh, and I'll say for British, and then 80 and 1.8. Okay, let's do the visualization right away. Line number 1. Jim is going to point to a new object over here, and the type of the object is person. And then, since we got 4 attributes over here, so we're going to have 4 rows over here. So we have age, nationality, weights, and heights. So age, nationality, weights, and heights. And these are the 4 input values that will be passed to these 4 parameters, right? As we said before. Okay, I'll just do that. We got 50, we got British over here, and we got 80, we got 1.8. Okay, that's exactly what line number 1 will do. Okay? Every time if you got a new object creation using the new keyword, that's how you visualize it. Line number 2. Let's try the following. Let me use a different color. Line number 2. Now, if I say, let's say double. Let me just make it easier. What about just print line? Print line, I say Jim dot get BMI. First of all, you can see that Jim over here is the context objects, which refers to the Jim I just created, right? So they refer to the same objects. Okay. Now we try to put everything together. Okay. So now, when you say Jim.getBMI, we know that we are trying to call this particular method over here, getBMI. And every occurrence of this is going to be replaced by Jim, okay, as we said before. And we know that what this will return is going to be something like this. What this will return is going to be exactly 80 divided by 1.8 squared. Okay, that's what we know. That's line number 2. Let's do line number 3. Line number 3, we're going to call some mutator method. So when we say Jim dot gain weight by, let's say 10 over here. Again, the Jim over here talks about the same Jim, okay, the same context objects. And now, when you say gain weight by 10, as we learned before, it's going to increase W over here, right? Jim.weights, okay? It's going to increase it by 10, okay? So that means what we're going to have is no new object creation, but replace this by 90, right? That's what we said in the previous notes, okay? Now, line number 4. And I'm going to use green again for a particular reason. I'm going to copy verbatim exactly what line number 2 says, exactly the same. I want to execute the same line verbatim, just once more. Okay, now I'm going to say number 4 here. Number 4. If I say print line, Jim dot get BMI, you can see calling the same method here, get BMI. Also, I'm talking about the same context objects. Am I going to get the same result though? No, right? Because you can see that from line number 3, which was executed before line number 4, we have already changed the value for W to be 90. And now, applying the same definition for get BMI, it's going to apply the same formula, but now the weights that will be used in the formula will be 90 instead of 80, right? So now, that's something you should really try to understand. Okay, now over here, Jim.getBMI over here is going to return 90 divided by 1.8 squared. Calling the same method, especially accessor method, may give you a different result because in between, you may have some mutated methods which will change the attribute values. Okay, that's the lesson to learn from this particular example. Okay, are we okay? So, of course, this is only a simple example. As we move on, we'll see more and more complicated example. Okay? Let me just, first of all, write it down. Basically, when you say Jim dot get BMI, like that, and also, you also got Jim dot get BMI. Over here, you got the same context object. Also, you got the same method over here. Now, whether these two lines will give you the same result depends on if the attribute values for the context object gym have they been modified already. Okay? So now, over here in the middle, if you try to do gym dot gained weight by 10, okay? That means what this will do is gym dot weights increased by 10. And as we know before, get BMI, what does it do? You will boil down into gym dot weight divided by gym dot height multiply gym dot height, right? So this, just write it down very quickly. So this is gym dot weight divided by gym dot height multiplied by gym dot height. Okay? And how about here? The same way as you calculate before, the same. Also, gym dot weight divided by gym dot height multiplied by gym dot height. The same formula. But now the only difference is, you can see that, let me highlight it over here. We can see gym dot weight has been multiplied, has been incremented by 10 because of the gain weight by mutated method call. In that case, if you compare gym dot height before that versus gym dot height after that, they are different. So that's why the return value for the same method call will be different. Okay? Questions about this? Are we okay? Yes, go ahead. Last slide. Yeah. Oh, okay. You mean I simply just do gain weight by without gym? Good question. The question was, what about if I do this? Okay, let me answer this very properly, okay? So now, it depends on where you use it. Okay, I'll give you two examples, okay? The question was, let's say I try to do gain weights by, but now I don't say gym dot. Let's say ignore the gym dot part, okay? Now, I'll give you two cases. One will be valid, the other one is invalid, okay? Now, let's first of all talk about the, let me give you an invalid case, that's easier, okay? Let's talk about utilities, which you're familiar, right, from your practice test. Let's say we got class, let's say person tester, how about that, tester? Let's say person tester, okay? And then we say public static void, and then we got a main method here, okay, something here. Now, let's do exactly what you said. So now, let's say for some reason, I simply say gain weight by if I just do that, that's what you meant, okay? If I simply do that, no, it's not going to work, okay? Let me just hold the reason for just one moment. I will show you another case where also saying gain weight by was okay. I'll tell you why, okay, in just a moment. Let me just do another, I'll just use a different color. What about class over here? Let's say we talk about person. Gain weight by is a method in the person class, person. Okay, over here. And then what I would say is, remember we got void, and also let me just define the context very clearly. Gain weights by, and then we got, of course, the parameter over here, and you got the definition over here, okay? That's not important anymore. We just know that the method is defined in the person class. Now, let's say that this, if I try to declare a new method, let's say void, and then I'll just say n. Okay, so now if I try to say gain weight by, pretty much like this. Let's say 10. Okay, now what does that, is that okay? I can tell you that this is fine. So we really want to compare these two cases side by side. So that's why I said the context is very important. Okay, let me explain why. One case is okay, the other one is not. Implicitly, whenever you try to call a method without some context object dot, implicitly it's going to be this dot, implicitly, always the case, okay? So now let me just erase this, this one here and erase this one here. Okay, let's see this. Implicitly, this is equivalent to this dot. Implicitly, this is also equivalent to this dot. Okay, the same principle. Every time, if you try to call a method, either as a helper method, most likely helper method, without any context object dot, it must be this dot. That's the rule. Okay, so now tell me something. In this case over here, what does this refer to? Does it refer to some person objects or what objects? It refers to actually some person tester objects. On the other hand, what about this case over here? It refers to, well, since we are currently under the context for the person, so it's referring to some person objects, right? So now, the only thing we got to decide right now is gain weight by a method of person? It is. It's right here. That's fine. And then we try to say, is gained weight by a method of person tester? No. In this case, no. So that's why it does not compile. Let me go a little bit further, just a little bit further. Okay? Let me just expand the second case just a little bit, but you might be wondering, if we do this, then how is it going to work? Let me expand just a little bit further. Let's say over here, okay? Just like that, okay? Now, let's say we try to test the person. What we will do is we'll say person, again, person, I'll say Jim is new person. Okay, let's say whatever value it is, just ignore that, okay? So now, when I say Jim dot M, what's that going to happen? Let's be careful, okay? If I say Jim dot N over here, N here is referring to the M over here, right? So now what's this right now? Jim, because Jim is the context objects. Jim is the context objects. And so this is going to be replaced by Jim. So when you call Jim.n, it's going to indirectly call Jim.gain weights by, which is exactly what we said before. Okay? Let me just recap. So it's a very good question. The original question was, what we went through before, we simply say Jim dot and Jim dot, right? The question was, what about we simply say gain weight by without any dot, okay? Now the answer would be, it depends on which context you're talking about. If we are in the person class over here, if you simply just get gain weights by, it's equivalent to just this dot, right? That this is simply referring to the person class over here. Similarly, the same principle applies. When I only say gain weights by in the person tester class, it also implicitly means this dot. However, this right now is referring to a different class because now we are in a different class. Now this is referring to a person tester, and person tester does not have this gain weight by method because this method here is only defined over here. Okay, it's quite a long answer to your question, but hopefully that's complete enough. Okay, guys, I know these two examples here are a little bit tricky, but you should really go through that and ask me questions during the lab. Okay. You should know that. Okay? Okay, any other question about this? Okay, we're moving slowly in the object orientation lecture. That's intentional because I do want to cover everything in thorough details. If you have no question, let's switch the topic a little bit. I want to talk about loops. Okay? So I think today we only got until 4:20, maybe about 40 minutes or so. What I want to do is I want to go over the syntax for two loops, do some example in Android Studio, and then we'll get to the tricky examples later on. Okay? But the loops lecture is going to take a long time, so I want to do very steadily. Okay? So now what I want to do is I want to switch the gear to loops. Okay? But I believe you learned a little bit about the loops back in 1012, but we'll actually give you lots of great more details in this course. Okay, let's go to the loops. All the lecture notes are also online. You can feel free to study ahead and ask me questions, but we'll just go from the beginning in the lecture. Let's go for some syntax. I'll also show you how you can write some example code for yourself on Android Studio. Okay, loops. So the learning outcomes for this particular lecture is we're going to understand about loops or iterations. So basically, why do you want to do loops? This is the one-line summary of why we need loops. Basically, you want to keep repeating similar actions. You will find that without loops, there are many, many interesting problems you simply just cannot solve. Okay? Now we'll talk about the problems in a moment, but I'm just trying to say, whenever you want to keep repeating something similar, you cannot just write them out explicitly. For example, I want you to print out "Hello World" 1,000 times. How can you do it? Well, of course, if you want, you can write one and then copy and paste for 1,000 times. That's one way to do it. But let's make it more general. Let's say, remember the scanner class we learned about before. Let's say this. I want to make some interactive scanner, interactive program in the console. The user is going to give you some integer. Let's say, for example, you are the program, I'm the user. I give you 10. You are going to print out "Hello World" 10 times. If I give you 20, you're going to print out "Hello World" 20 times. If I give you 20,000, you're going to print out "Hello World" 20,000 times. Now imagine that in your program, can you actually predict what I'm going to tell you as an integer? You actually cannot. All you can say is integer I is assigned to scanner dot next int. That's all you can do. But what I really type on the keyboard to tell you to do, you have no control over. In this case, what you have learned so far without any iterations just cannot solve it. Okay? That's why we want to teach you about loops. Once you learn about loops, you basically can solve almost many, many interesting problems, which will give you maybe in lab number 5 and 6. Okay? The rock, paper, scissors game that you actually did is actually an example where you don't have a loop. But I'll give you some game in which case you do need a loop. Okay? That's something we'll do a little bit later. Okay, now there are two common loops that we're going to cover in this course. One is called for loop, and the other one is called while loop. So the reason for these two keywords, I will try to explain with some intuition to you, but these actually come from a C programming language, because Java is the successor language to C, so it keeps all the convention there. Okay, we're going to talk about for loop, and we're going to talk about while loop. One thing I want to mention, even though we're going to show you maybe the typical cases for either for loop or while loop, in theory, they are completely equivalent to each other, which means whichever problem you can solve using a for loop, you can definitely translate it into while loop, and vice versa. Okay? So don't be too surprised if I give you some problem there, I say, now translate this for loop structure into while loop, or vice versa. Okay? That's something we'll get into. So you shouldn't say which one is more powerful. You can only say each one might be more suitable for one occasion, but not the other. Okay? Okay, we're going to talk about primitive versus compound statements again. Primitive means simple. Compound means complicated. What can be the compound statements? You might have some if statements inside a loop, or you might have a loop inside an if statements. You may have a for loop inside a while loop. You might have a while loop inside a for loop. Okay, things like that. It can be as complicated as you need it for solving your problem. Okay. Okay, yeah, exactly about nesting, but we'll get there. Okay, I'll also talk about some logical errors and pitfalls, but we wouldn't get there today even, but we'll gradually get there eventually. Okay, motivation. So for example, you may want to repeat similar actions for so here, the word here, bounded number of times. If you know exactly how many times you're going to repeat a particular action, this will be a very good use case for loop. Okay? For example, you want to print out "Hello World" for 100 times. Why don't we try to do that right away? Okay, let's do that. I'll also introduce you to the syntax. Okay? So let's now create a new class over here. Let's say new Java class. Let's say, I'll just say loops. Okay, like that. Let's see what we can do for the loops. I want to show you the syntax for both for loop and while loop. Okay. Okay, you know what I should have done, I should call that loop tester. By the way, it's also a good thing to show you. How do you rename a class in Android Studio? I would suggest don't do it manually. Do it systematically using the refactor tool. I'll show you right away. It's a good point, good time to show. If you right click on your class name, and then you can go to refactor and go to rename over here. Okay, that's the best way to do it. It's going to also rename the file for you as well. Okay, so now let's say rather than loop, let's say loop tester. Okay, and refactor, and it's going to do it. Okay, that's much safer. Okay, and then we're going to put a main method here, public static void main string args. Let's learn about the syntax. Okay, let's learn the easiest way. So now we can say for loop. Use a for loop if you know exactly how many times a block of code is going to be repeated. For example, 100 times, 1,000 times, 2,000 times, etc. So now how do we write it? Okay, let me do it on the iPad first, and then we'll do it on the Android Studio. Let's learn the syntax. So this is how you do it. Okay, for loop. Okay, so now there's a keyword you have to learn, like a new keyword, right? So you have for, for loop. You're going to put some parentheses, left parentheses, and then right parentheses. Curly brackets, and then closing curly brackets. Okay, what's going to go inside for the for loop? This is how I remember it. First of all, there will be 3 parts that you can specify in the for loop. Okay, and the 3 parts are going to be separated by 2 semicolons. So now you got the first semicolon here, and here you got the second semicolon, like that. So now let's, first of all, before I show you an example, let's learn about what each part is. Okay, first part, second part, and the third part. And the first part simply means something called initialization. Initialization simply means when you first execute a loop, you're going to do something just in the beginning, only once. Only once. No repetition for the initialization, only once. Okay? And then the middle part is the most complicated part. The middle part, first of all, is going to be a Boolean expression. And now when we talk about Boolean expression, that means it's going to be an expression that will return either true or false, right? And to get more complicated, remember in the selection lecture, which we'll continue to finish maybe next week. In the selection lecture, we talk about logical operator. We talk about logical negation. We talk about conjunction. We talk about disjunction. So you can use different sorts of combination of Boolean operator inside the middle part. Okay? Boolean expression. And what is it for? It's something called state condition. So what do I mean by state condition? So that means as long as, I'll just say SC over here, state condition. As long as the state condition is true, keep repeating. Keep repeating. Repeating what? Repeating so-called the body of the loop. So this is so-called the body of the loop. No, actually, sorry. So the body of the loop. Okay, I'll give you an example in just a moment. I want to explain the terms first. Okay, there's state condition here. What about this part over here? This part is more like to do some updates. Updates. And the updates, as opposed to initialization, is going to be repeated. However, the place you do the updates is crucial. Okay? Updates at the end of each repetition. Okay, I just want to know, you got actually 3 parts over here. You got first part, second part, third part. Also, you got the body of the loop. Okay, you got these 4 things to worry about for the for loop. Okay, let's see one example, and then I'll put it on the Android Studio. Okay, let's see one example. What about I say something like this? I say for, okay, now I can do some initialization just for once. A typical one, I can say integer I is assigned to 1. Okay, that's perfectly fine. Okay, semicolon. So that means I'm going to execute this particular initialization for just once. And I over here has a special name. We call it a loop counter. So very often for every loop, you need at least one loop counter to actually help you to somehow keep track of where you are in the loop. Okay, we'll get in there. Okay, but in general, you can have as many loop counters as you like. Okay, depending on how complicated your loop is. Okay, and then after this, we got also the state condition. Okay, let me just put it over here. It's called a state condition. Okay, let me give you one example. It's a Boolean. Let's say we are going to print out hello world 100 times. Let's say 5 times. How about that? Okay, I less than or equal to 5. So that means as long as the value of I is less than or equal to 5, we're going to keep repeating the body of the loop. As soon as I has become larger than 5, which will make this Boolean condition false, in that case, we're going to exit from the loop. Okay, well, just very informally, and then I'll show you how you can do that. Okay, and then over here, this is updates. Update, let's say I++. So you should be very familiar with this as well, right? I++, that means I is assigned to I+1. Okay, update means we want to make sure it's definitely a very bad idea to have so-called infinite loop. So infinite loop, which means a loop that never terminates, never terminating. So this is very, very bad. Okay, we'll see many examples like that. Okay, hopefully you will see example by yourself as well in the lab. Okay, okay, now let's say that, and let's make something very simple. Okay, what about the body of the loop? Okay, let's say print line. Okay, print line over here. Hello world. Like that. Okay, just like that. So let's first of all type this into Android Studio, and then to see exactly, we're going to get exactly 5 printout of hello world, and then I will try to go over the meaning of the for loop with you. Okay, using some flow chart. Okay, we'll see that. Okay, and let's see exactly how this program is going to work. Okay, let's convince ourselves that this one is really going to print out 5 only. So you can say for, okay, integer I is assigned to 1, I less than or equal to 5, I++. Okay, so far so good. And then we'll say system and other print line, hello world. Okay, like that. So everything compiles. Let's now go to project over here. I will select loop tester over here, right click, and then I will run it and see exactly how many hello world we have. Okay, let's wait for that. In fact, in your lab test, it will be a little bit faster than this, which is good. Okay, let's count exactly how many we have. It should be 5. 1, 2, 3, 4, 5. Okay, why don't we just play with it a little bit before I show you the meaning of for loop in just a moment. Let's play with it. Okay. Now, let's say I want to change to say rather than printing 5, I want to print out 6. There are different ways I can do this. You want to suggest? There are different ways I can change this to print out 6. One way to do it is I can say, rather than saying I is less than or equal to 5, what about 6? That's one way to do it. Let's double check. Let's try that. Okay, 1, 2, 3, 4, 5, 6. Okay, that's one way to do it. You can rewatch the recording to see the different possibility I showed. Okay, another way, which may not be so intuitive to you, but you got to get very used to it once we cover arrays. Okay, now what about I say 0 over here? That's the last one to show you. 0 and then less than 5. Can you get your head around? I'm saying that I start with the loop counter being 0, and then as long as I is less than 5, I'm going to stay in the loop and then repeat the body of the loop, which is going to print out hello world. And then at the end of each iteration, I'm going to increment the value of I by just 1. Okay, that's exactly what it's going to do. Okay, let's convince ourselves it's really going to return actually 6. Okay, that's should be 0, 1, 2, 3, 4, 5. So maybe what I meant to say was this, right? It's very confusing. Even myself can get wrong. Okay. Why don't we try? Okay. Okay, let's see how many do we have over here. Let's count. 1, 2, 3, 4, 5, 6. Okay, it seems to be okay. So now we got 6. Okay? Now, of course, let's, if you just play with the example to get an idea, that's not the best way to go. But I just want to show you this is how you can play with the loop. But now I want to show you exactly the meaning for the loops. Okay? So now let's go back to our iPad over here, and then let's show. This one flow diagram, which I'm going to repeat right now, and then you can see that that's the flow chart over here, which I'm going to draw on the iPad to show you. Okay, but that's something you can go over when you study the slides. Okay, let's see that. So now let me just highlight the different parts over here for you. So let me use different color. Let's say initialization, I'm going to use green. Okay, now for the state condition over there, it's going to be very important. So let me just use pink over here. And then over here, let's say updates, orange. And then for the body of the loop, let's use possibly blue. Okay, I just basically show you different parts of the loop. Let's see exactly how this is going to be executed. Okay, let's see that. Now, the initialization part, which is the green part, is only going to be executed once. So what I will do is I will first of all just put the green one over here. I'm going to draw the flow chart. Okay, so this one here, I'm also going to write it down as well. Integer I is assigned to 1. Okay, just that. Followed by the state condition check. It's a Boolean value, which can be either true or false. So now over here, I'm going to have the pink over here. And then it's going to be either true or false. So I'm going to say I less than or equal to 5. Okay? And then, now, first of all, is this going to be true or false when I is equal to 1? True. What does true mean for the very first time? That means we're going to execute the loop body for at least once. We're going to enter the loop. Okay? And then we're going to, the next step will be to execute the body of the loop. In this case, of course, the body of the loop has only one line. In general, the body of the loop can be arbitrarily complicated, which we'll get into a little bit later. Okay? So now we're going to execute the body of the loop, which will be blue. Over here. And then over here, I would say print line. Okay, I'll say hello world. Like that. Okay? And then what will be the next? So this is the trickiest part. You can see that I said that the update part over here is going to be done after every iteration. So every iteration is going to execute the body of the loop. So at the end of that, we're going to do this updates only once, okay, after each iteration. So what we will do is we're going to do over here. Okay, over here, this is the updates, and then we're going to say I plus plus. Okay, so this is after the updates. Now what? Basically, after the updates, because we might have to execute things repetitively, so now after this is a crucial thing. So after this, we're going to go to over here. What does that mean? After the updates, check the condition again. If the condition happens to be true, then we stay in the loop. That's why it's called a stay condition. If the condition happens to be false, in that case, we don't have to stay. We exit from the loop. Okay, let me complete the picture a little bit more carefully. So that means over here, when we simply go from this condition over here to here, that means the condition is simply just true. I'll put T here. But what if it's false? If it is false, we simply just go exit from the loop. So this is when it is false. Okay, that's a flow chart. Okay, now let me just highlight a little bit more. So when you say true, that means stay in the loop. And when it's false, it's exit from the loop. Okay, why don't we try very carefully now? I'm gonna just sketch a little bit, and then we also got example on the slides. Okay, let's do this one first. Okay, so now you can see we're gonna trace the loop. Let's just trace the loop for when I is initially 1. Okay, that's how we trace it. Okay, let's try to see that. Let's see I over here, the value of I, and also I less than or equal to 5. And then we also got some action. Action in general can just be the execution for your loop, the loop body. Okay, let's see what we're going to do. So now let's try to be very careful. When we first started over here, I is going to be just 1. Okay, 1 less than or equal to 5 give us true. That means we stay in the loop. We're going to execute the body of the loop, and then I would just say print. And then after that, we're going to execute the updates over here, and then we're going to say I plus plus. Okay? So after this, what's I's new value? 2. So you can see that it's really important for this particular I plus plus. Imagine this. If we ignore this I plus plus, that means I's value always stay as 1, which means this condition here is always true. That means we never ever exit from the loop. That's the infinite loop situation, which will give you 0 for the lab test. Okay? Hopefully you wouldn't have that. And also for exam. Now, how do we continue with this? Okay? So now you can see that I plus plus is eventually going to cause the state condition here to be false eventually at some point. Okay? But we'll go one step at a time. When I is equal to 2, and then we check for this condition again, 2 less than or equal to 5, true. That means we stay in the loop. And then we execute the print statement again. So that means we do print, and then we do updates. I plus plus. Okay? And now, I's new value is 3 over here. Okay? And you can see that this kind of process is very mechanical, tedious. That's why it's automated by the compiler, by the Java runtime machine. But for you to write some code that's logically correct, you must understand what you're writing as a loop. Okay? So now, what about number 3? So now we're going to check this again. Okay? We go back here and check it again. 3 less than or equal to 5, true. And then we execute this print line statement again. So we're going to say print, and then I plus plus. Okay? And then we're going to have 4. We don't exit just yet, not yet. So now we say 4, and then we come back here. Okay? 4 less than or equal to 5, true. And then we're going to execute the body of the loop, the blue one, is going to be print, and then we're going to say updates I plus plus. Right? Now what's the new value? 5. Now what? If we got 5 over here, that means over here, 5 less than root of 5, we're still okay, right? So not yet, okay? I thought we are now trying to exit, not yet. So now it will still be true. Okay, let me use consistent color here. Now it will still be true. And then that means we'll print, and then I++, okay? Okay, let's continue with that. Okay, sorry. Continue with that. So now, I++ from 5, so now we got 6. Now, go back here and check it again. 6 less than root of 5, false. False. False, what does that mean? That means we're going to, so false over here, we're just going to take this particular path over here. That means we don't try to execute the body of the loop. We don't do any further updates anymore. Just exit. Okay, so now you can see how many times do we print out. 1, 2, 3, 4, 5. Okay, I think that the main idea about this illustration over here is you should know very well how the green one, how the pink one, how the orange one, and how the blue one should be in place. In general, they can be arbitrarily complicated, as we'll see, but you should really know it very well. Okay, I want to show you just some alternative over here. Okay, there's actually different ways that you can write a for loop. Okay, let's see how we can do that. So now, if you do for integer I is assigned to 1, I'll do the same example. I'll show a different way of writing it. I is assigned to 1, I less than or equal to 5. And then we say I++. Okay, over here we say print line. And then we can say hello world, let's say. Okay, that's one way to write it. Okay, I'm going to show you 2 other ways to write it. Another way to write it, you can simply, because we know that this part over here, let me be consistent with what I put as a color. This should be green. Okay, we know that the green one for the initialization over here is only going to be executed once. So we can imagine that it's as if we try to do this particular initialization right before the loop. Okay, so there's another way you can write it. You can do that simply like this. Integer I is assigned to 1, and then we do the for loop. And then just leave the initialization part empty, but you should still put the semicolon. That's really required by the syntax. Okay, so here just empty. And then I less than or equal to 5, and then I++. And then we have print line here. Okay, and then we got hello world, like that. Okay, the second way for you to write it, 1 and 2, they are completely equivalent. Okay, what about a third way? There's another way for you to write it. I'll try to squeeze the space over here. Let's say that's number 1, that's number 2. What about number 3? For number 3, it looks like this. We still put out the initialization over here, and then we'll do, okay, you know what? Let me just do the third one in the next slide. I don't want to squeeze too much. Okay, how about this here? Number 3, also equivalent to 1 and 2. You can do initialization over here, integer I is assigned to 1, for loop. The first part has been done already, so empty. The second part, I is less than or equal to 5. Now, let's say the third part, because we know it should be at the end of the iteration. It should be. Okay? What we can do is we can say print line, and hello world. And then we simply put I++ at the end. We should simply just put it there. Okay? So number 3 is completely equivalent to 2 and 1. Okay? So which means if you write number 1, which is the most commonly used syntax for loop, it's completely equivalent to 2 and also 3. Okay? But there's something I want to warn you about. Okay? Is about the where you put I++. Okay? I remember I got some example in some later slides. If you actually put I++ over here, it is equivalent to putting I++ at the end. However, in general, you don't necessarily have to put I++ just at the end. You can put it, let's say, in the beginning as well. Okay? So let me say, so far we got 1 is equivalent to 2, equivalent to 3. Okay, I'll show you something very quickly. And then we'll see why, maybe next time. Okay? Number 4. Integer I is assigned to 0, and 4, integer I is assigned to 1. Oh, sorry. I think I meant to say 1 here. And then empty here. And then I is less than or equal to 5. And then, now, let me do the following. I say print line, hello world over here. But now, I put I++, not as the last line of the iteration. Okay? Now, what I can tell you for now is number 4 is not equivalent to number 3. It's not equivalent to either of the above example we talk about. I'll talk about this kind of tricky case maybe next time. Okay? I think we still have some time to go over some syntax. Okay? Any question about this? About syntax, for loop? Okay? Let's go back there. Let's go over some. Okay. So now let's do some little bit practice over here. Let's say we have this. Let's say we got for loop. Now the loop counter I start from 0. And then we say that we're going to stay in the loop and repeat the body as long as I is less than 100. Okay, starting from 0, as soon as it becomes greater than or equal to 100, we're going to exit from the loop. And then at the end of each iteration, we're going to say I++. Okay, now I got 2 questions for you, 2 questions, and both are important. Okay, I'll write it down on the iPad, and then we're going to think about it, and that'll be it for today. Okay. Okay, I will copy exactly what I have, 0 and 100. Okay. Less than 100, let me just make sure that's right, okay, and I++. Okay, and then we have the body of the loop. We simply just print out, that's a welcome, that's just a welcome, okay. To really test your understanding, let's try to answer the following 2 questions. Question 1. How many times? Okay, we know that let's be consistent with, I believe it's blue. This is the body of the loop. How many times the blue part will be executed? Question number 1, how many times exactly? How many times? Question 2. Okay, question 2 is, let's now look at the state condition over here. I less than 100. We want to know exactly how many times we're going to check this condition here. Either the result can be true or false, but how many times are we going to check? Okay, okay, I'll write it down. How many times this will be checked? Okay, let's think about this question here. Of course, this applies to any for loop in general, but I think it's really important for you to understand the difference between these 2 questions very carefully. A little bit hints for you. I want you to look at question 2 first. Question 2 simply means, how many times are we going to check this? We know that this is a Boolean condition, which can be either true or false. We know that as long as this is true, we're going to stay in the loop and keep repeating. As soon as it becomes false, we're going to exit from the loop. That means it's going to be evaluated to a number of true and plus 1 false, right? And the number of trues is going to correspond to a number of times we're going to execute the blue part. Okay, that's kind of the idea. Okay, now let's, due to time constraint, let me go over that with you, and then I will say something about the, Let's go back there. Now let's say this. Initially I is simply 0, and then 0 less than 100, we know that it's true. So we stay in the loop. We stay. And then we're gonna execute the body for the first time. Okay? And then you can see the I++ over there is gonna increment the value by 1. And then we go for 1 over here. 1 less than 100, true as well. And then we enter for the second iteration, and etc. Now, question for you. What is going to be the value of I, which is going to make I less than 100 true the last time? Last time. 99? Right, it's obvious, right? Because as soon as I gets to 100, 100 less than 100 is going to be false. Very good. Okay, so now, exactly this pattern over here. So now you will see that 99 still be true about the last time. Now, as soon as I++ occurs, we get 100. Now, do we stay in the loop or exit? Yes, false. So that means we don't bother to stay in the loop. You can see exactly how many iterations we have, 100 times. On the other hand, how many times do we check this condition here? 101 times. This one difference here is important to really for you to get an insight. You got a number of truths which correspond to the number of iterations you have, and the final time you get to false, in which case you don't repeat anymore and you exit from the loop. Okay? That's basically all you're gonna understand for the for loop. Okay? Let me just stop the recording here, and then we are pretty much done.